This video is going to go through the review for our test on Unit 4, Modeling with Functions. Let's take a look at problem number 1. Lily sees the following sequence, and we can see there are smiley faces at different n values. And she says that the model for this sequence is this recursive function where f of 1 equals 3, and each value f of n can be found by f of n minus 1, remember this is our previous value, plus 2 times the n value. So let's real quick realize that here we have 3 smiley faces, 7 smiley faces, 13 smiley faces, and 21 smiley faces. So we want to either show that she's correct by creating a table of values and showing all the arithmetic, or show that she's incorrect and modify the model to make it work. So let's start by seeing if we can make a table. So I've got n, and we've got f of n. And we have n values 1 to 4. So obviously f of 1 is 3 because I count 3 smiley faces. So check. Okay, so now f of n, so if I'm looking for f of 2, I'm going to write this one out down here. If I'm looking for f of 2, using the formula, I'm going to find f of 1 plus 2n. And in this situation, n is 2, so I'm going to go 2 times 2. f of 1 I see is 3. 2 times 2 is 4, so this becomes 7. Check, that works. Okay. All right, so let's see if this gives us 13. I'll do that one in green. So now, if we go f of 3, that should equal f of the previous value, f of 2, plus 2 times n. Well, f of 2 is 7. 7 plus 6 is 13. All right, well, that one works. Okay, so now we'll do f of 4. I did not need this big of a table. So f of 4 will equal f of 3 plus 2 times n. n is 4. f of 3 was 13. 13 plus 8, yep, 21. So it works. I've made a check and a 1 at the same time. Check. Okay. Number 2. The graph of two functions is combined to the right. The function graph is the result of combining two functions, g and h. G is a sine function. What type of function is h? Explain why you chose your function. So if I'm being told that g is a sine function, so a sine function, so just as a note, this is 3, which is kind of close to pi, and this is 6, which is kind of close to 2 pi. And I see that my curves are going up to 1, just like a regular sine function would, but over here where it would normally come down, it's been reflected over the x-axis. Like this part right here normally would be down here. So what type of function do I think h is? I'm pretty sure h is an absolute value, and here is why. H of x is an absolute value function because all the negative y values of the sine function have been reflected over the x-axis. That is why I feel fairly confident that this is an absolute value function. All right, number 3. A boat appears on a radar screen. Its path is shown on the xy coordinate grid below, along with its location at various points in time in seconds. And below it says, on the coordinate grids below, sketch the graphs of the horizontal motion of x equals f of t and the vertical motion y equals f of t on the interval. So I'm going to do a little cutting here. I'm going to pause the video and just do a little cutting. Okay, so now you can see your graph, and now I've got a little version here that I can move around. So what I'm going to do to sketch the horizontal motion and the vertical motion is I'm just going to make a real quick table. I'm going to say I'm going to say t, and then x of t. In other words, what is the x value at each of those times? So I can see on my original graph that I have times 0, 1, 2, 3, and 4. So I'm going to just make a table, 0, 1, 2, 3, and 4. And at 0, I see I have an x value of -3. At 1, I have an x value of 1. At 2, I have an x value of 3. 3 has an x value of 1. And 4 has an x value of 4. So I'm just going to plot those points, t, and you see my what used to be my y-axis is now it says x. What used to be the x-axis now says t. So I have 0, -3. I have 1, 0, 2, 3, 3, 1, and 4, 4. I'm just going to connect those real quick. Okay, so now I'm going to do the same thing for the vertical motion. So I'm a little graph over here. I'm going to do the same thing. I'm going to make myself a table. Oops. How do I make X first? Is that like your gut instinct, X, Y? Really got to be careful with these parametrics. So we have T and we have Y of T. All right, so here we go. I'm looking at the Y values, and I notice that 0 and 1 both have a Y value of -4. Kind of boring. And then 2 has a Y value of 0. 3 has a Y value of 2. And 4 also has a Y value of 2. So when I go to plot those, I've got 0, -4, 1, -4, 2, 0, 3, 2, and 4, 2. I'll get them connected. And now we have a graph that separates the horizontal and vertical motion of the boat. All right, number 4 says, consider the function f of x graphed below. The function g of x is defined as the absolute value of f of x. So the first thing I want to do to sketch g of x is I kind of want to identify some good points. So I'm going to take a look at my graph, and I see I have a point at -4, 0. And I also have a point at 2, 0. Now, the absolute value of 0 is just 0, so I'm just going to graph those the way they were. Now, I also notice that these curve up. I don't have any really nice points here, but the absolute value of a positive y value is still a positive y value. So that point. Well, okay, so now I'm going to find, I've got a point at -1, -9. So again, we're taking the absolute value of the y value. So if I do g of -1, that's going to be the absolute value of f of -1. I know f of -1 is -9. And the absolute value of -9 is +9. So -1, +9. And I could do a few more if I wanted. I could look at this point right here. I've got 0, -8. I've got -2, -8. That might be enough. I think I can get one more. I think I've got 1, -5 becomes 1, +5. And then I've got -3, -5 becomes -3, +5. And there we go. It says explain the transformation of f of x to g of x. So what did we do? We kept all the pieces that had positive y values as they were, but any part of f of x, any portion of f of x that produces sorry, I'm a bad speller, produces negative, and a bad typer, y values will be reflected over the x-axis as the y values are made positive. Cool. All right. Number 6. A sample of soil is enriched with 200 milligrams of fertilizer every day at noon. The soil processes the fertilizer such that every 24 hours, 20% of the fertilizer is no longer effective, meaning that 80% of the fertilizer remains. Create a mathematical model that will allow you to determine the amount of fertilizer in the soil immediately after the application each day. Be sure to define your variables. So I'm really feeling like a recursive function would be good here. And the reason I say that is that I see that there is an initial value of 200, and then something is happening every day. So what I'm going to do, because we are adding fertilizer every day, and there is a percentage of decline in the fertilizer. So when I make my model, I'm going to have two variables. I'm going to have n is going to be what day we're on, fertilizer, days since we started adding fertilizer. I'm just going to go with day. That's sufficient. And I'm going to say f of n is going to be the milligrams of fertilizer in the soil. And I'm going to start this such that I'm going to start with day where n equals 0 is the initial application of fertilizer. Okay, so let's take a look. This means that f of 0 is that initial application of 200. Now, every day, f of n, I'm going to start with the previous day, and I know that 80% of the fertilizer remains. So whatever was left over from yesterday, I'm going to multiply that times 80%. 80% as in decimal is 0.8 or 0.80. Then, because they get every day, I'm going to do another application of fertilizer. So it says the fertilizer is effective in the soil once it reaches a level of 600 milligrams. On which day is this fertilizer first considered effective? Show how you determined your answer. Well, the easiest way to do this is just with a calculator and just to create a table. So I'm going to create a table. I'm not really sure how long it needs to be. I know day 0 is 200, and now I'm going to pick up my calculator and I'm going to show you how best to put in a recursive formula. So on my home screen, I am starting with 200. So I'm going to go 200. Now this answer is going to be like my f of n minus 1 because that's my previous answer. F of n minus 1 is previous answer. So I'm just going to do previous answer times 80% plus 200. And that's going to be 6. So on day 1, we feed the soil, and now the soil has 360 milligrams of fertilizer. So now here's the awesome part. If I just keep pressing enter on my calculator, it's going to repeat this calculation for me. So previous amount, 80% plus 200 is 488. So on day 2, after we apply the fertilizer, there will be 488 milligrams. On day 3, after applying the fertilizer, I will have 5. Oh, we're getting there. And remember, this is after we put in the 200 for the day. So let's see what day 4 is. There it is. Okay, and sure enough, we've got 672.32. It says, on which day is this fertilizer first considered effective? So I'm going to say on day 5, and I'm going to be really, really clear, or not on day 5, sorry, on day 4, after the 5th application of fertilizer, the fertilizer is effective. Okay. Now, letter C says, the fertilizer is considered safe to use as long as it never exceeds 750 milligrams. Use your model to determine whether this fertilizer is safe. So what I'm going to do is I'm actually just going to continue my table from up here, and I'm going to say, all right, well, I know that N, F of N, I'm just literally going to recopy that last value for, let's keep hitting enter a few more times, and let's see what we get. Let's see what day 5 is. Grab my calculator, enter, all right, so 737, 856. I mean, we definitely can see, like, the growth is slowing. Like here, the level jumped 160. Here it jumped 128. Like, it's definitely starting to level off. The question is, will it level off before it hits 750? Let's find out. Day 6, fail. On day 6, after that application, we're going to be at 790 we'll just go with 790.2. 790.2. So, on day 6, and remember, day 6 is actually the 7th application after the 7th application of fertilizer. The level exceeds today. Okay. Question number 7 says, consider the line modeled by the parametric equation below. Using the parametric equation, at what t value does the y-intercept occur? Now, we need to remember that every point on the y-axis has 0 for x, and then there's a y value. So what I'm actually going to do first, at what t value does the y-intercept occur, I'm actually going to, use my x of t equation. And I'm going to say, all right, well, when is that 0? So if I say 0 equals 2t minus 3, 3 equals 2t, divide by 2, t equals 3/2. Okay. Now, using the parametric equation, identify the x-intercept. Well, we know that this x-intercept occurs when t is 3/2. So I'm going to substitute 3/2 in for y. So -4 times 3/2. So I'm doing this without a calculator, not a big deal. I'm going to think about this as -4 over 1. And now -4 times 3 is -12. Divided by 2 would be 6. -6. And then plus 2, I find out that the y-intercept is -4. Eliminate the parameter to write the rectangular representation of the equation. So when I look at this equation, x equals 2t minus 3 and y equals -4t plus 2, I notice that if I multiply the x equation by 2, that would give me 2x equals 4t minus 3. And then, because this is 4t and the y equation is -4t, that would allow me to eliminate the parameter if I added these two equations together. I would get 2x plus y, the t's will cancel out, equals -1. Using the rectangular equation or representation, what is the slope of the line? So wait, I made a mistake. Pause, back it up. That should be, it should be -6. My bad, guys. Hopefully you were like Strauss, you made a mistake. And then this should be a -4. All right, so using the rectangular equation, what is the slope of the line? The first thing I'm going to do is I'm going to take my line, 2x plus y equals -4, and I'm going to write it in the form y equals mx plus b. And all I need to do for that is subtract 2x. And now I can see I've got -2x minus 4, so the slope is -2, and the y-intercept is -4. Ta-da! All right, number 8. A baseball player hits a ball with an initial height of 4 feet, an initial velocity of 100 feet per second, and an angle of 45 degrees with the horizontal. Write the parametric equations. So I want to go back and read this really carefully. I have an initial height of 4 feet. That's my y sub o, my initial height. We have an initial velocity of 100 feet per second. That is my v sub o. And we've got an angle of 45 degrees with the horizontal. That is my theta. So now I can substitute these values into the two equations in the box. X equals the initial velocity, cosine theta, t. Y equals the initial, gravity, plus 100 sine theta, t, plus the initial height. Okay. What do the variables represent? Well, first off, let's just make a little quick note. The reason we want to remember the reason this is cosine, like we have a baseball player. Here's the baseball player. Here's the bat. Here's the ball. And he is hitting this ball 4 feet above the ground. And he's hitting it at an angle of 45 degrees, and it has a velocity of 100 feet per second. The reason that this is 100 cosine 45 theta, or 45t, is because if I look at the horizontal, I could set up an equation that said cosine 45 equals x over 100. And then solving, I would get the first, after 1 second, I would get the 100 cosine 45 times time. Depends how long, because this is a rate. Okay, and then the same thing here, gravity, initial height, and then this is how high it travels. Setting up, I could set something up where this is y, and then this would be sine, and then this is y. So that's interesting to note for those of you who are like, wait a minute, remind me where these came from. Now, what does t represent? I want to go back to my explanation here to pull out some units. I see that we are working in seconds, so I immediately know that t is time in seconds since the ball is hit. X is going to be the horizontal distance the ball travels, and y is going to be the vertical distance the ball travels. Now, we are told explicitly to graph these with the following settings. Now, you have a copy of these on your paper, so I'm going to cover up some of the settings. Let's get the calculator going here. Now, as a reminder, if you are borrowing one of my calculators, or maybe an older sibling's calculator or a friend's calculator, please check your mode and make sure you are in degrees. We've got 45 degrees here. That's what tells me it needs to be in degrees. You're also probably going to need to change your mode to parametric mode. So you can see under mode, I've gone from function, and I'm going to change it to parametric. If you have anything in your equation, go ahead and clear that out, and I'm going to enter 100 cosine 45. Make sure you close your parentheses. T and negative 16 t squared plus 100 sine 45 t plus 4. Now, let's remember how to do this. I'm going to pop these out so you can see what my equations are. I'm going to reload that, and you can see that's there. So now what I'm going to do is I'm going to go to my window settings, and I'm going to change the window settings to what it says on my paper. And it wants me to have a T-min of 0, so I got that, a T-max of 10, a T-step of 0.1. I'm also told to have an X-min of 0, an X-max of 400, man, this ball is really going far, and a X-scale of 100. Now that's just so it doesn't look so crowded. That just means I'm going to have scale marks every 400. Now, the X-min of negative 50 is not because we expect the ball to go under the ground, but just it's nice to have some buffer space at the bottom of the graph. 150, and we'll scale every time. So, let me see, view. Let's change this table to the window. So if you need to see that, oh, you can see it already kind of updated it for us. When I go look at my graph, there it is. That is a perfect, the ball comes up, and then it comes right back down and hits the ground somewhere. And because I counted these by 100s, 1, 2, 3, a little more than 300 feet away from the baseball player, the ball will hit the ground. So we've got some questions to answer, and we're going to need our calculator to do this. Find the time at which the ball hits the ground. Round to 1 decimal place and include units in your answer. So to find out where the ball hits the ground, I'm really wondering what is the value here. And it specifically says what time the ball hits the ground. So what I'm going to do is I'm just going to hit trace. I'm looking to see where that y value is as close to 0 as I can possibly get it. I'm going to switch my view so it's a little better for you. There we go. All right, so now I'm just going along here. Oh, that's pretty good. It looks like it's right there. Let's see, this is negative 1.8. Let's just go above. Yeah, that's 5. The other one's better. So I know that at 4.5 seconds, so that's 1 decimal place, 4.5 seconds. And I'm probably going to need this. I'm going to not go with this real quick. So here we go. I'm just going to make a real quick little graph here, just for my own reference. I know this is right here. This is 4.5 seconds. I bet you we're going to probably need this information. This is 318.198, and it should in theory be 0. So, when does the ball hit the ground? At about 4.5 seconds. And just as a reminder, we know this because the vertical height is about 0 at 4.5 seconds. All right, letter B says find the maximum height of the ball. So now if I'm finding the maximum height, I'm really looking for this point. So I got to go back to my calculator. And I'm going to trace to about this point here. So I'm going to go back, and I'm looking for the highest y value I can possibly find, because I'm looking for the maximum height of the ball. I want to make sure I read, 81, 82, 81. No, all right, we're going to go with this as the maximum height of the ball, 82.123. As a max height of 81. I feel like it was 82. Yeah, no, it was 82. 82.13 feet. And just as a note, we trace for the highest y value. Okay, determine the total horizontal distance the ball travels. Oh, yes! We already know this, guys. It's right here. Right here. Look at the highlighter. Right here. Boom. Right here. This is because at 4.5 seconds, when we're about at 0 on the ground, we see the ball is at 318.198 feet. 318.198 feet is the total distance the ball travels. So just as a note, how do I know this? When y is about 0, the ball is on the ground. And I see that x is 318.198. I hope that was helpful.